Okay, so now there was this question about how piecewise functions are created from an absolute value equation. So I'm going to kind of give you a graph that goes kind of along with it, so that way we can kind of figure out what's going on uh, graphically as well as kind of algebraically. But probably the easiest thing is if we have some function and it's an absolute value function, we can make it kind of as complicated or not as we want. So maybe we have this, okay? Now, the graph of that function, and I'm not going to give you a really detailed graph here, but let's see, 3. But it's going to look, something like this, okay? Now, the piecewise function, really kind of graphically what you're doing is you're splitting it right down the middle. And then you're going to have one piece for the right-hand side and one piece for the left-hand side. Okay? So if I want to do that, then maybe the easiest is if we think about the function, y. Now, the absolute value can have two cases, right? Either that 2x plus 1 is positive already, so we would have this equation. So that would be 2x minus 2. Or we could possibly, that part of what's inside the absolute value is a negative, and we would need to change its sign. So that would be a negative 2x minus 1 minus 3, just distributing that negative. So then we get a negative 2x minus 4. So my two pieces then look like this, but then I've got to figure out where the domain restrictions are, okay, and stuff like that. So might be easiest, we know that those two pieces have to be equal at that spot, so maybe that's the easiest way to do it, because what we're looking for is where those two lines cross. Okay. So 2x minus 2 would have to equal the negative 2x minus 4. So that would mean 4x has to equal negative 2. Okay. Right, add that, and so then x is going to have to equal negative 1/2. So I guess I should have drawn it a little bit more accurately. Would have been right here. Okay, and we're looking at that split down the middle where x is a negative 1/2. So this piece is when x is greater than equal to negative 1/2. And this is when x is less than negative 1/2. Now it doesn't matter in this case which one I put the equal to on, because they're both the same at that spot. So that might be the easiest way to rewrite it. And you'll notice if you do isolate just the right-hand side, look, there's the y-intercept. It is at negative 2. It has a slope of 2. So you could write that equation, 2x minus 2. And this one, if you extend it down, has a y-intercept at negative 4 with a slope of negative 2. So that kind of matches everything up. So that might be the easiest way to do it. But picture-wise, you're just kind of splitting it down where that little V, the tip of that is. The trick algebraically is if what's in the absolute value is positive, then you don't have to worry about it because the absolute value of a positive number is just itself. But if the absolute value is negative, then to make a negative number positive, you would have to multiply it by negative 1, right? And that's the key for this part. I mean, just consider the absolute value of negative 3 is a positive 3, right? Now, if you took a -3 and multiplied it by a -1, you would get exactly the same answer, right? So that's why I stuck that negative out there in front. So hope this helps a little bit.